attention, your note up there, to look at both of those graphs and then their parent function, the equation that I've highlighted. Look at both of those and think about, on the left one you've got the square root graph. So how does that square root compare to a parabola? What's the degree of a quadratic of a parabola? What's the highest power of a quadratic or a parabola? Squared, right? Remember that? It's ax squared plus bx plus c. And so here I've got a square root. What's the degree on a square root? Use your power over root trick. 1/2. So I've got a degree of 1/2 graphed on the smartboard on the left side, and you know what the graph of a parabola looks like. So how would those two graphs compare? How would you describe that one on the left side? How would you compare it to a parabola? Very good. It's like half a parabola. I could draw a bottom half of this right there and make a sideways parabola, right? Okay, so instead of squaring, we've square rooted. So that's like undoing that parabola. It's half of it. Okay, what is the degree on this thing? 1/3. Remember what third degree graphs look like? The disco. So this one, it's just kind of turned that disco graph a little bit. Instead of them pointing down and straight up, they're more to the side a little bit. So it still takes those same characteristics. I wonder why on a square root one, everything is positive. Look at those domains and ranges. Very good. If you take square root of a negative, it's imaginary, right? So it has to be positive in there. Now, does that mean that every square root graph is going to be here? We can do those same things that we've done to every function to move it. Stick a +2 on the end to scoot it up 2. Stick a -3 in with the x to scoot it right 3. All of those same things will still apply on that. Okay? And you're going to see those today. I did not make you a table to copy down like we have every time, but the transformations are exactly the same as always. I thought if I put that piece of tape in there, that would help that not fall as much, but it didn't. All right, so let's graph a few. So we got f of x is equal to the square root of 1/4 x. Okay, before we talk about graphing, and we're going to do always by hand, making an input-output table, and we'll do it on the calculator also, but compare this to the parent function that we just drew. What's different between the one I've got on the board now and just the square root of x that we saw on the first one? Very good, we got a 1/4. And we remember from all of our transformations earlier in the year, if we put a 1/4, or if we put a number times something, it was either going to shrink it or stretch it, right? So same deal here. Our question is that 1/4 in front of the whole function, or is it just in with the x? Just in with the x, which makes that be vertical or horizontal? Horizontal. Very good, horizontal. And on horizontal, do I keep the 1/4 or do I take the reciprocal? Reciprocal. So this is going to have a horizontal stretch of 4. Okay, we've done that. I'm not going to spend a gazillion minutes going over that because it's the same stuff that we've done this whole semester. Now to graph this, you can do it a couple of ways. I'm going to start by making an input-output table. So I'll just pick a number, plug it in. If I plug a 0 in for the x, 1/4 times 0 is 0. The square root of 0 is 0. So I know it's going to go through the origin. Now, if I'm just picking random numbers here to plug in, and I see the first thing I do when I plug a number in is multiply it by 1/4. Might be smart to pick like multiples of 4, you know?
Like 4, 8.
Okay, so if I plug a 4 in, 1/4 times 4 is 1. Square root of 1 is 1.
No, 8, 2, 1, 2.
I'm gonna count on every one because Garrett's going up on my 8 now, which is a good. 1/4 times 8 is 2. Square root of 2, that's not going to be a whole number, obviously. Go ahead and hit square root of 2 on your calculator and give me a decimal approximate. So almost 1.5, so 5, 6, 7, 8, 1, and right around in there.
16 be your next whole number one to be next.
Okay, that'd be a good one. 16 times a fourth is 4, and the square root of 4 is 2. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 1, 2. Okay. So you get a little curve looking something along those lines. Kind of flat, and think about the reason why it is flat. That transformation that Maddie helped me label at the very beginning said we were horizontally stretching that, right? So if we were horizontally stretching that, the points that would normally be closer over here, we drug them out there. So it made that appear to be flatter like that. Okay, grab your graphing calculator. See if you can graph that in your calculator. Remember, f of x is the same as y. So hit your y equals on the very top line.
Wait, you got 16 too?
Mm-hmm. And it went off of my graph over there by where the arrow is.
Oh, okay.
You got it, sir. These calculators, I say this every year, they're not like megapixel, high def, 1020, 1080, whatever it's called. So they don't give you the best picture, but you still should get something that's got some similarities of that. And then you ought to be able to go to your table. You ought to be able to go to your table and get some points, right?
Why did it do that?
Let's see. You don't have anything typed
I
in?
just cleared it because
Oh.
it did a straight line.
Okay, type it again. That's good.
I don't know what I did wrong. It wasn't like all the way across.
Anybody else need calculator help?
You just put
The original equation. We were just learning to use our calculator and do without both. Anybody else need calculator help?
yeah, I mean, right now.
Okay, I'm on my way that way.
Nope, I got it.
If you don't put the x, that would just be a straight line. Because that would mean it's y equals the square root of 1/4 all the way across.
Now,
Got it? What do you got going? Okay, what happened when you hit graph? Alright, hit zoom. 6. There it is. Hit your y equals and switch you down. Is your x underneath that square root? Yeah, don't you have an x underneath or something? Clear that out.
This is what I got right now.
Now just move it, yeah.
That's what I did.
That's right. I think that's what it is. Yep. Y'all are good, y'all are good. Never
I saw your truck right now.
I want to do one more of these before we look at something different. F of x is equal to the cube root of negative 8x. Okay, I want you either make an input-output table like I did and plug in some points, or type it in your graphing calculator and go to your table and get some points. But I need you to have actually plotted a few points on this. if I were working this one on my own, this would be a time when I actually would use the graphing calculator. Got it, Nate? Start bumbling and look at me. I don't know if that means you need me or not.
Oh, wait.
We're gonna have fun with it.
What happens
This
is
is a lot. Yeah.
go down to the go-to, see if it'll show us your list. It doesn't want cube. Did you type that cube up there?
Yeah.
Yeah,
Clear
mine
that,
doesn't work.
clear that out. Clear the whole thing out. Hit math, go down to number 4. No, clear that out. That's okay. There you go. Now try. There you go.
I forgot where the, oh, never mind, I found it.
Anybody else need some calculator help?
Yeah, mine.
I found it.
Here, broke it.
It says 3.
Okay, go to go-to, and maybe it'll show us where the error is when it comes up there again.
Wait, how do you do the graph? Or the, not the graph, the table.
Second graph. Easy killer. Don't scare me over there. All right, Chloe, give me just 1 point I can plot.
1 negative
1 negative 2. Okay. Hunter, give me another point I can plot.
Negative 1, 2.
Negative 1, 2. Grant, give me a point I can plot.
-2, 5, 6.
Negative 2 and 5 halves. 1, 2 and a half.
What, 0, 0, 1?
Well, is it on your table?
Yes.
Okay.
-4.
What?
8, -4.
1, 2, 3, 4, 5, 6, 7, 8. 1, 2, just put it in there.
Wait, would you have to borrow this one?
No, I was just asking you.
Oh, I'm fighting 3.
1, 2, 3, 4. Ooh, that turned it way out. Okay. So let's see if I can draw through what y'all gave me. I gotta spread out. I gotta scroll up and down. Alright, so there's what I got when I connected the points y'all gave me. How does mine look compared to your screen?
Similar.
Pretty good?
Very
Pretty good, pretty good?
You just figure out how to plug it into the calculator.
Good. Time saving.
Better than mine.
Now,
It's Hungary. High school, Massachusetts, fall.
okay, what if we were told to graph this? Talk to me. What if we were told to graph that?
Well, you have to set it to y.
Okay, very good. If you're using the graphing calculator, it's not ready because it doesn't have the y all by itself. So I'm going to do what Chloe said and solve it for y, set it to y equals. Now, I know, and you do too, that this is going to be a sideways parabola when we get it done. Because we got a squared, it's a parabola, and because the squared is on the y, it's sideways. So I know it's going to look like that when we get it done. Alright, so first thing I would do to get the y all by itself is I got to get rid of a 1/2. And there's a couple of different ways you can get rid of a multiplication of 1/2. You can say, well, that's dividing by 1/2, but what's dividing by 1/2 the same as?
0.5.
Multiplying by 2. So I'd be looking at 2x.
square root it.
Okay, then undo the squared by square rooting. Now here's what you have to remember because your calculator doesn't know this.
Well, it would have been the same answer if you divided by 1/2.
Yeah, it would have.
Go back.
When I undo the squared and square root, you know it's got to be plus or minus. So here's how you're going to have to enter this into your calculator. If you don't, you'll only get it half right. You're going to go to y equals, and you're going to enter the positive square root of 2x, and then you're going to go down to the next line and enter the negative square root of 2x.
It's a split and go to.
Well, hit go to, and let's see what it tells us the error is. Don't put a positive, delete that, because it's wanting you to add something. There's some that, and there's the one. Very good. Okay, I looked on Grant's, and I don't have any specific points yet, but his was a sideways from the origin right there. Is that what everybody's seeing? Okay, what you'll have to do, and I'm going to write down a couple for you here in just a second. You'll have to be able to go to your table and get a couple of points off of it. So I'll write me a little table over here. I know I got a 0, 0. Tell me a couple more whole number points. 18, 6. What else you got?
0, 0.
I got 0, 0.
2, 2.
2, 2. One more. 8 what? 8, 4. Okay. Now, on that opening note that you copied down where I had those parent functions, it discussed the domain and the range. Domain, remember, is the x's. So, is this domain ever going to enter negatives? No, it's going to the right forever. So, if I was asked to tell the domain, I would say x has to be greater than or equal to 0. Right? Everybody okay on that? Range is up and down. What happens to this parabola the farther out it goes?
It gets wider.
Keeps getting fatter, keeps getting wider. So it's going to go up forever, and it's going to go down forever. So the range on this would be what? All real numbers. Very good. You could write it out, or you could use that symbol like I did on the opening notes with the R with the 2 legs up there.
Mine doesn't have the bottom thing. It says air.
You're up to negatives.
We're,
I got it totally different.
See?
Oh my gosh. Let me see.
I just got done describing that x can't be in the
Put the
negatives.
second one.
This is negative x over here.
This one?
You've got y's that are negative. Look in the y category. Scroll it down. See, look, y's are negative.
Oh, I'm looking right here.
Well, that would be the top curve.
Oh.
Y1's the top curve and Y2's the
Oh,
bottom
I
curve.
got you. Thank you.
Did y'all figure out what was wrong?
This would be like this.
I don't know what you did. I just retyped it like you did it before.
I'm so smart. You right?
Now, you could even graph a circle doing what we just did. Let's see if we can figure that out. I've got x squared plus y squared equals 16. Okay, well, we need to get the y by itself. So the first thing before we do that would be to subtract the x squared. Okay, so we're going to subtract x squared from both sides. So we'd have y squared equals 16 minus x squared. Now I'm trying to get the y by itself, but it's being squared. So I'm going to undo that by square rooting it. Now here's a common mistake people are going to make every single time. It is going to be positive negative, but don't do this. You can't just say, well, I'm going to square root each of these terms. That doesn't work like that. It's like, it's almost identical to when we first started, and I don't even know if this marker works, and we saw this, and y'all wanted to just square those individual terms. Remember, you can't do that. That's that whole quantity. You would have to write it twice and multiply it out. It's the same thing here. We don't get to square root those individual terms. We have to square root the entire quantity. So when we do that, it's really less work for you. Plus minus, like Laney Joe reminded me, you're just going to leave that whole thing underneath the radical. Okay? Now, when you go to type it in your calculator, remember there's not a plus minus sign, so you'll have to type them in separately. Type the first one in, square root of 16 minus x squared, and then go down to the second y and type the negative one in. Now remember I told you about your calculator's graphics. They're not the best, so your circle's kind of distorted and choppy, but it is a circle with a radius of 4.
Looks like an egg.
Yeah, that's what
It is crosshairs.
Oh, I think that's an egg.
What's that been on yours, Belle? Yeah, our calculators are not high def for 2020 or whatever those numbers are. It's kind of choppy and distorted. She's got negative in there instead of
Yeah, like after 5.
Joe's look as good as mine?
Nope.
No.
I haven't even graphed it.
Look at mine.
He's used to shape.
She did. Did you not watch her do it? It's not even a perfect circle. That's stupid. That's dumb.
It's okay, Michaela.
No. He said it looks like my head. He said it looks like my head.
Oh, me, oh, my.
I'm so happy that I could.
Okay, so y'all get listening ears on real quick so I can kind of tell you what my plans for the rest of the semester are. My little emergency dentist trip yesterday did throw a wrench in it, which y'all will probably be glad. But anyway, originally I had planned we were going to finish this unit and do a test right before the Christmas break. We might still could, but it would have to be way fast and way crammed. And with those exponent rules that we did day before yesterday, we still need to do some more practicing with those than we wouldn't get to if I tried to cram that test in. So that's on one hand, but now on the other hand, I got to drag stuff out to make it last another week and a half or whatever we have. So tomorrow we're going to have an assignment over these graphs and the exponent properties that we learned the day before yesterday, and those solving equations like we learned that y'all did with that sub yesterday. So we'll have an assignment that mixes all that together on one of those little quiz worksheets, you know, but it just mixes all that together. Then when we come back next week, we're just going to spend that week practicing with the exponent properties. Do a different assignment each day and practice with those exponent properties. Okay? And we'll do that. I've got planned to do that Monday, Tuesday, Wednesday, Thursday, and then Friday, the following, not tomorrow, the following Friday, we would start with our semester test review.
So we won't have a test before we do.
Correct. And you can think of a bad tooth
See,
for
and
that.
I really
But-
I appreciate that.
But it's gonna be lots of assignments.
So you
So there are
grade 'em.
still gonna be lots of grades.
Good.
That's good because if
I
I
gotta
get on
see.
those, it'll get my grade.
Yes.
Because right now I have a B and 3 absences, so I can't like, I can't,
What?
I'm not taking this test.
Oh.